All right, so the example from the end of class today. So it's a 20 kilogram box. We're pulling up at an angle of 53.13 degrees with a force of 400 newtons. Coefficient of friction is 0.3. And the question is, what is the acceleration? So like in the other examples, we're going to start with the sum of the forces in the y direction. And even though you're pulling upward, you're not actually lifting this box. So MAY is 0. So it'll be Fn going up minus Fg, which is going down, plus Fy, because this time the y component is going up. Always trying to solve for Fn. So take the other two over, so it'll become Fg minus Fy. So Fn will equal mg minus, and the y component is the opposite side, so that will be F sine theta. Again, you could get values for this if you want, but I'd probably leave it and I'd go to sum of the forces in the x direction, equal to max. So in the x direction, we have Fx pulling forward and friction pulling backward. Fx is F adjacent side, so it's F cos theta. And friction, we know, is mu Fn, is equal to max. We want to get the ax alone, so we're going to divide by the m. And so it'll be F cos theta minus mu. And instead of Fn, I'm going to fill in this bracket mg minus F sine theta. And you have to put it in brackets because both of these terms need to be multiplied by the mu. And then we're going to divide by this m to get the a alone. Okay, so now we're going to fill in our numbers. So Ax equals, F was 400 newtons, cos of 53.13, minus mu was 0.3, brackets, 20 kilograms times 9.81 meters per second squared, minus 400 newtons sine of 53.13, close the bracket, and the whole thing gets divided by 20 kilograms. Okay, so either then you do this in your head or you find your calculator. Cos of 53.13 I think is 0.6 times 400, so that's going to be 240. So the first term is 240, and I'm doing this in case some of you still can't get the right answer. And then in brackets, 20 times 9.81 is 196.2. And then sine is 0.8, so this will be 320. Oops. And then it's going to be divided by 20 kilograms. Ax is equal to 240 newtons minus, so this is... actually, I'm probably going to just save time. I'm going to go here. Minus brackets 0.3 times brackets 196.2 minus 320, close the bracket, close the bracket. So this is going to be a minus 37.14 newtons over 20 kilograms. So in the top you're going to have 277.141 newtons, on the bottom 20 kilograms. And so Ax is going to equal 13.857, like a number of you were saying in class, meters per second squared. Okay, so that's the answer to the example from class. I also promised you that I would do number 3 on the displacement and equilibrium force questions because we didn't get to it. So number 3 says, a motorboat wants to travel to a restaurant on the opposite side of the river, west 53.13 degrees south. So you're up here and you want to go west-south. So you want to go down here, so that this angle in here is 53.13 degrees. Okay? If you keep reading, though, it says the river is flowing to the east. So if you aim for this spot, you're going to end up down here because the river's flowing to the east. So you need to aim further west and let the river, it's supposed to be an arrowhead, carry you east. And it says the river is 10 kilometers per hour east. And then if you keep reading, it says the person on the patio of the restaurant sees the motorist moving at a rate of 45 kilometers per hour. So this is what the river's doing, this 10. This long one is what the motorist is doing with respect to the river. And the short one is the resultant. If you're standing on the patio of the restaurant, you see the resultant. So this side is the 45 kilometers per hour. If this angle up here is 53.13, then so is this one, which means this guy must be 126.87. And so you have a side, an angle, an included angle and a side. So you're going to use the cosine law. Because the question wants to know the velocity of the boat moving with respect to the water, this side. So v squared will equal 10 kilometers per hour squared plus 45 kilometers per hour squared minus 2 times 10 kilometers per hour times 45 kilometers per hour times the cosine of your 126.87. V squared equals, if you type all this correctly, the V, not the V squared, because I didn't write the V squared down, you get 51.624 kilometers per hour. So this time the question is different because I gave you the resultant and I asked you what the velocity of the boat was with respect to the water. I asked you one of the component sides. And if I was a betting nun, that's probably what messed a few of you up. You probably put the 45 on as a component. Second part says, what direction must the driver aim the boat to end up? So the angle that we can find will be this one. The angle that we can find will be this one. The angle that we need is the one outside. So we can find theta, and I'd probably use sine law now. So sine theta over 10 kilometers per hour will equal, and you have to use the sine of 126 because that's the only angle you have, 0.87, and it's going to be over the side you just found, 51.642. Okay, so then, sine theta will equal 10 kilometers per hour, sine of 126.87 divided by 51.624 kilometers per hour. And when you do this, you get a theta here of 8.9149 degrees. So this is the angle inside the triangle. But if you're going to give directions, you need it with respect to the east or the west. So we can find our other angle. It's going to be 53.13 degrees minus this 8.9149 degrees. And when you subtract that, you get that outside angle to be 44.215 degrees. So what would the direction be? We're measuring off the west, 44.215 degrees heading south. So this is part B. This is part A of number 3. Okay, we also didn't look at number 4, and I have 1 minute before this video runs out, so I can at least set it up. It says 3 siblings are fighting over a stuffed animal. One child pulls with a force of 84 newtons west, 50 degrees north. So that's going to be here. So your F1 out here, 84 newtons west, 50 degrees north. So this will be your F1x. This will be your F1y. The second one is 62.5 east-north. So here, this angle is 24 degrees. 62.5 newtons is F2. Okay, and then F3 is southeast, and this is the one that may have messed you up. Southeast is in here, and this is 55 degrees.